Hey, everybody. Welcome to this episode of Build It Better. So excited here today to have, you go by True Adam, True ADM, not True Adam, but True ADM. But Dominic, Dom, D.
Dominic's good.
Okay.
D23 as we've learned earlier.
Dominic, we're so excited to have you today. You've done so many really, really, really cool things. And, in kind of the midst of all the Svelte releases and people getting really excited about Svelte 5, even though we y'all just released Svelte 4, everybody's been saying, ooh, Dominic's working on some cool stuff. So maybe we're not going to talk about all that cool stuff today, but I think, your background with the React team and this and that and whatever, we can kind of get into that. But first, I want to go ahead and introduce myself. My name's Tracy. You can follow me on Twitter at LadyLeet. And I'm joined by my two co-hosts.
Jesse, you can follow me at Tomchak at threads.net and moth.social.
You can change your little thing there. That
I
says
know.
Oh, okay. Threads.net. Is that the meta thing?
Yeah.
Crazy. Who's speaking there now, Adam Barrett, sometimes known as Big AB at techhub.social. And our guest today, of course, as Tracy's already said, is Dominic Gannaway. Bring him a hand.
Hey, everyone. So you can follow me also on Twitter and threads at TrueADM.
Yes. See, me and Dominic, we're on the bleeding edge.
I got to hop on that Threads train.
Oh,
yeah.
I did watch Mark Zuckerberg yesterday introduce Threads in an Instagram video.
Yeah. You wait until they federate, and then all of my content and work this year is just going to come pouring into your eyeballs. It's going to be amazing.
So, Dominic, I heard that you named hooks, which, is that how everybody should introduce you at conferences? Like, Dominic, the dude who named hooks. And then everybody who's mad at hooks can
Is that a positive?
I was going to say,
do you want to figure him out like that?
Well, the funny story about that was we, as a team, were trying to decide. We had the concept, the sort of implementation, everything kind of almost ready, but we didn't have a name for it. And they had a placeholder name of augmenters, which we weren't too sure about having.
It's a chewy name.
So we kind of put together,
Helpful.
I think Sophie put together a document with hundreds of names. And I think I just randomly suggested hooks, which at the time was already kind of used in terms of lifecycle hooks. That was already a thing. But we thought maybe we can use that and call them lifecycle methods or something instead. So we got away with it, and I think hooks was actually quite a good name. The whole premise of having use kind of felt like you were hooking into something logic and hooking it into a component. So it kind of went from there, really.
Do you remember any of the other names on this list? I'm thinking super callbacks or
No. It's React. So the other names were probably function and closure and all names that already have a meaning, but we want to take that meaning and make it mean something else.
Well, I think we like the name traits, which was something other languages already had.
Oh yeah, traits actually would be a really nice one. That's interesting.
But, yeah, we went for hooks. I can't remember. It's a while ago now. The exact naming list we had. I know there were some wacky ones on there. Thankfully didn't make it. But yeah, that was a cool bit of history. And I think what was kind of interesting as well was we weren't too sure about hooks, whether or not it would be as well received as we hoped at the time, because there's obviously moments in sort of framework history where releases haven't gone as well as expected. And so we were a bit anxious whether or not this change sort of would add to fragmentation. So it was also about how do we message this in a way that is clearly a better strategy than using class components. And at the same time, it was dealing with a space that kind of came from prior research. So as a team, we were looking into a React compiler and using a project called Prepack, which started 2017 or 2016. And it had a team based out in Seattle that were working on this. Initially, the project was for React Native. It would optimize the bundle, initialization times for React Native. And how it worked was it would actually evaluate your JavaScript ahead of time against the spec, so it actually did everything properly. and it would try and actually compute your logic. And where things were unknown, they were treated as abstract. And so that it would then generate and serialize all your code at the end. It would like fill in the gaps and work things out. It was remarkable actually in how it worked. So we looked at that as a way of trying to sort of leverage that to make the React compiler. And we got it working. So we actually had function components at the time. We didn't support class components actually compiling. So you'd have an entire component tree all inlined into a single component, which was kind of crazy. And it was maybe, I want to say 80 to 90 components that were fully inlined, and it was passing tests. So the whole output was still 100% what it was before. The downside was it didn't actually improve performance at all because you've now inlined 90 components into a single 100,000 line component. And if you know about how compilers work in inlining, when you have an if statement or some conditional logic that branches, you then have to like inline all those trees. So you essentially duplicate code. So then we were like, how do we change that heuristic so that we can like uninline things and bring back the performance, you know? But what actually led to was that we found a difficulty in understanding the this keyword in JavaScript. And when you have this, it leaks everywhere because you can pass it to things, you can bind to it, you don't know what happens and it can mutate, etc. So anytime somebody would reference this and pass it to a function call or something, we'd have to like serialize out the entire world of what we knew this was at that point, which kind of undid all the performance gains from having a compiler. So that led to us deciding, well, maybe we can actually build a new sort of like stateful React based on function components that actually avoided this problem altogether. And additionally, it would play well with this world of concurrent rendering that we wanted to pave the way for in terms of how you can deal with effects, how things can be unwound and played back and suspended. So it was a sort of double whammy of like trying to adhere to compiler and then also trying to make concurrent rendering more effective. So it kind of achieved that in some ways. And I don't know if you've heard of React Forget, which is kind of a newer effort that's happened in the last year or so that is kind of respawning, not Prepack, but like the effort in terms of like how to do a lot of the work ahead of time, in terms of memorization, in terms of runtime efforts to improve performance and code size. All that work kind of is still like very much happening now. And so it's kind of cool that's now happening again. Obviously it happened after I left Meta. But like, that's kind of been an interesting thing. And also from my experience as well, working with compilers, it kind of was like a really nice fit because around the time that I was working on Prepack, I remember speaking to Rich Harris and go, hey, look what I've been working on. And he was like, oh, look what I've been working on. I've been working on this new sort of like Svelte compiler. And it was just really interesting to see how the ideas were kind of like merging together, even though we hadn't even spoken about compilers at that point. And
in my head, I'm thinking, so Prepack took these 70 or 80 components, and when you say compile them inline, is it doing the V8? Like, so V8 does the runtime compilation and execution and holds a bunch of stuff and in the stack. Is it like pre-doing some of that process?
So basically, we kind of taught it how React works. So we taught it like JSX and also non-JSX. And so where you reference a component with some props, we kind of treat it like a function call where you then get the reference to that function and then you call it with the props that you know and some that you don't know. And you evaluate that and then you kind of get that output and kind of build up your own internal stack and then rebuild it in terms of you serialize it back out to JavaScript AST. So you put it all the way back to it. So there's no sort of low-level V8 operations occurring. It's more we were trying to actualize sort of like the runtime without knowing the runtime. It's kind of weird to explain. And there are things that you can try and do, but you just avoid doing. Like if you enter a loop, there's a thing called loop unrolling, is you can actually derive the loop. And it gets very complicated. There's a lot of sort of like sort of theory and prior research and papers around computation, math, and the sort of things that happen with compilers.
So
there are far smarter people than me that have worked on these, but I came into the project without having any compiler experience. I didn't even have to use Babel AST. I had to kind of learn everything from scratch. It was kind of like a major imposter syndrome. I just joined this company, having worked in Inferno, got thrown into a React team, which is a very like sort of like a league of its own in terms of engineering experience, and like learning how to build compilers was.
That's really fun. Have you ever talked to Jay Phelps about compilers? He's like obsessed.
No, we've bumped in a few times. But I don't think we spoke about compilers.
Oh my
you
God.
guys could geek out for weeks.
I know. He like on airplanes, he'll like print out like books and read them about compilers. He's really intense about it, but he's actually the one that first introduced me to functional components in React before hooks was a thing. So this was like back in like, I think 2017 maybe. And he's like, functional components are better, Tracy. This is how you do functional components. I'm like, why doesn't everybody do functional components? And so, a few years later when functional components became a thing, I was like, well, duh, this is great. But yeah, you should really talk to Jay. We should do another Build It Better with Jay.
And just make them talk about compilers.
Yeah.
And we could get really like into the theory and the whatever. That would be pretty cool.
Yeah.
I would listen to it. Before we get back to this conversation, I would like to take a brief word to talk about our sponsor, This.Labs. This.Labs is a consultancy that specializes in application development and upgrading legacy systems. They've been trusted by leading companies like PlayStation, Capital One, Herman Miller, PayPal, and T-Mobile. This.Labs enjoys serving as a crucial bridge between business and technology facing challenges with legacy systems and need to modernize. Well, This.Labs brings extensive experience in enterprise migrations and upgrades, providing a detailed roadmap for modernizing your software solutions. Their engineering leaders are industry veterans with a deep understanding of modern technologies and best practices. They're prepared to consult and execute complex solutions with their team through staff augmentation or other means to ensure timely delivery of your projects. Learn more about how This.Labs can help you achieve your tech goals at this.co. That's THISDOT.co. Now let's get back to the show.
This.co.
Love it. Like an old radio show. I love it.
I always think like that old timey radio, like where everyone sits around when Adam goes into his radio voice.
I love it.
Yeah.
All right. So we were talking. You just mentioned you were on the Inferno team. You moved to the React team, and then of course now you're on the Svelte core team. And you're talking about using compilers most of these times. But then you said you didn't know how to do compilers. So what were you doing in the Inferno bit?
So that's a good question. So I knew about the very basics of compilers. When I say compilers, it's like there's no compilers, and then meeting people that really do know compilers who have spent, decades building low-level compilers in other languages, who have written papers that have been published for PhDs, and then you meet them and you talk to them, and you very clearly have a gap between the both of you. And so when I built Inferno, which way back in maybe 2015, I was always in this pursuit of performance. Performance was always like my thing. I really enjoy fine tweaking stuff, looking at the V8 output, seeing where things de-optimize.
Oh, who doesn't love looking at the V8 output? I mean, it's just, ooh.
You won't believe how many people don't like it. But yeah.
That's weird.
Sounds like a great Saturday night to me.
But no, I enjoyed knowing how things worked. Like, it's quite interesting because at the same time I was like interviewing for different sort of companies and stuff, and there's always this big thing about O-notation, about the O-notation this, and I was like, well, that doesn't work. Even though it looks like O to the one, in JavaScript it's actually O to the N if you knew how it worked under the hood in V8. It's kind of interesting how those all span out, but that was like what I was interested in. So when I was working in Inferno, I noticed that you could do much more with JSX other than create element from it, which was what everybody was doing. And so I thought, what if you could actually analyze the template and say, look, hey, this is a div that contains like 5 children. Thus I know that it's an array, so it has children and it's keyed. Or this is a div that contains some text. So thus I know that when I come to rendering it, I can do a fast path and maybe do like domno.textContent equals value. So the idea was to try and store that information inside like the sort of template. So when you parse the JSX, the code that you output isn't just .create element, but rather it can be like another call that contains flags that indicate the value. So using bitwise values that can explain that this is a particular thing that has this attribute, or this is a particular thing that has this. And that means that when it comes to the runtime can much more effectively update and diff, because doing bitwise operations, which is something the CPU is highly optimized for, is a lot more effective than looping through an object and trying to figure out if it's a function or it's a string, which obviously isn't as optimal as you can imagine. So doing those sort of operations at compile time meant that we just did less work at runtime. And this kind of planned out well, because Inferno was like, it still is very quick, even though it's a long time ago I built that. And the premise is like, that was how I started it off. And interestingly, Vue 2 or Vue 3 actually stole the same idea. I remember speaking to Evan, who goes, "Oh, I like what you did with bitwise operations and taking it from like JSX. We're going to do the same thing with our templates." So, that was kind of cool.
When you say bitwise, is that like metadata? Like when you bundle it, you're basically appending metadata to that so that the compiler knows, so that the V8 knows what to do with it?
Yeah, so you can imagine if you had like a function call to create element, and you say like, this is a div, these are the props, these are the children. With Inferno, what we did was we said, this is like a div, and here's a number, this is the flags, and then here's the props, here's the children. And because it's a single number, we can actually use bitwise to represent different values on it. So you can say it's both an array, it has this property and this property, and you can use a single like integer to do that. Versus having like a set of booleans on object that has like flags.
Does that mean you're limited to 56 flags if you use an integer?
I think we only ever use 10 or something.
Right. Okay.
You don't need that many, but like that just allowed for much faster parsing time, and obviously using a single number rather than many, so it's meant less overhead in terms of like reading it out. Also, when you like generate the actual output, you're creating less JavaScript, so the smaller bundles. So that was the idea anyway, and it panned out in real world applications. I think at the time, like before I switched from Inferno to the React team, was like it was like doing really well in terms of like usage and uptake. It still is today, from what I hear. Not a lot of people know this, but WhatsApp and even like parts of Facebook used Inferno in production to hundreds of millions of people every single day. And that's because it just performed much better at low-end devices. When you needed, like for example, there are parts of the world that use mobile devices on something called Kai OS, which is like a very sort of budget phone, where you don't have much memory at all. You don't have much CPU, so you're constrained heavily there. But you can't use React because it just eats up too much.
It's like a 15-second load.
Yeah, so it's constrained is to put politely. So that was kind of nice to see that Inferno had a place to be, because its only selling point was performance. It didn't really have any other big bets. It wasn't necessarily better than React, So I joined from the Inferno project to React at Facebook, and then sort of working on how we could improve performance. I did a conference talk in 2017 at ReactConf Europe, where I spoke about the sort of lessons we learned. And interestingly, I applied some optimizations from Inferno to React, and it didn't have any sort of impact at all to Facebook. And the reason why was, unlike typical applications I was used to, which you probably have like, 40, 50 components, maybe up to 100. You go to some of Facebook and then you've got 10,000 components loading on a page at once. It's like a different scale. And so a lot of the time was spent actually just like in your components, not actually in the framework itself. So those sort of optimizations didn't really have any impact for Facebook. So it was then thought, well, maybe we can look at this differently and use a compiler to like fix people's code, like make it fast, and so kind of that's where it all spurred from. That's kind of where it's led to today as well. And along that journey as well is I worked on the Facebook team, so the React team, for 2.5 years, and then I switched to sort of Workplace, which is kind of like a London-based team, and Workplace is kind of like a Facebook for business, corporate users and stuff. You can imagine it as a better Slack internally. And it was also something that everyone who worked at Meta used. It's like the internal communication tool. But when I worked in that team, I got kind of heavily involved in accessibility and spent a lot of time actually improving the core APIs around accessibility with the company, all the products and stuff that use that. And then that got me interested into text editing and content editable, which is a lovely beast. And that's where I kind of stumbled across what we used already, which was called Draft.js, and looked into how we could fix issues there, and then came up with the sort of end conclusion that we had to start again. It was just not right. And that's where I kind of like started working on Lexical, which was my next sort of like endeavor. That we open sourced that, I think, last year. So it's been a blur the last few years because of COVID. But like, yeah, I think it was last year or the year before we open sourced Lexical, and that was like a really impressive thing. We didn't really expect a text editor to be like popular or people enjoying it because it's such a niche thing, but it turned out actually people had lots of issues with content editable.
It's such a fundamental, like the text editor is such a fundamental building block that it hurts my mind how often I've reached back for like CodeMirror or Draft.js, because it's like, unless you're doing just the absolute bare minimum, and like the second you start to step up to like, okay, I need some sort of formatting and I need some sort of thing, like everything just falls apart in the DOM. And I'm just like, oh, the DOM was not meant for this. Like, this is so hard to do. So I've used Lexical. I'm really happy it exists. I was happy with JS, and I'm even happier with Lexical as a tool to sort of abstract all that away, because it's a bloody mess. Like, it was really hard. Like, I was like, I feel like I'm kind of smart, but like building a text editor in the DOM is just brutal.
I think that the thing that makes it the most difficult is that it's a free fall in that the APIs just are really flaky between browsers. And we work with the different browser vendors to try and fix these. But like, you know, one release to another, something would break. And what makes it difficult as well is that there's a whole bunch of extensions out there, Grammarly and different editor tools and spell check tools. They just modify the DOM directly. They don't even fire an event. So then the text editor's like, hold on, the DOM's has changed, and it's changed to this other thing. Like, what was it meant to mean? Like, did the user do that? And so what we had to do was we had to use a DOM mutation listener, and basically anytime something changed, we revert it back to what our internal state was, just for sanity. And that was one of the biggest issues with React and using React as an editor sort of output, is that if you change anything that React modified, you get weird remove child, append child, DOM issues, runtime. That's it. The page is broken, React won't work anymore. And that's because React doesn't expect you to change the underlying DOM. It expects it to control it. But in the content editable, you can't have that sort of expectation. So we had to build Lexical agnostic to framework. So it had its own renderer, its own sort of like virtual DOM, I guess. And do things differently to make it work. And then you have Android, which is another lovely kettle of fish, where everything is composition. So when you do a key press on Android, it's not actually a key press. You're typing in composition. There's no key down. It doesn't fire. So having to like...
Wait, what?
Yeah, you do get a key down event. The event code is 227, which just basically means you entered composition.
Oh, that makes me...
Yeah, so you have to work with that. And then you have IME, and that's when people use sort of like, again, composition, but like specifically for Korean, Chinese, and Japanese, you know, where you type in that format and having that work. And the truth is, with Draft, with Slate, it just didn't work properly. It broke very quickly. And so we needed to fix that. And at the same time, we couldn't use ProseMirror, because ProseMirror did things that we just didn't deem accessible. And accessibility was something we cared about.
Yeah, it's very much a black box inside of ProseMirror.
Yeah. So, for example, mentions, when you mention somebody like at someone's name, typically text editors keep that as like a token, so you can use the arrow keys and it jumps over it. And then, oh, this works fine. But actually, for somebody who's using a screen reader, that's terrible, because it doesn't read out the name now. And even if it did read out a name, people that use the screen reader want to actually go through each character, because someone's name when you read it out, it can be fast. You don't know if that John was spelled with a H or missing the H, or you don't know how this last name was spelled. So they have to go through character by character, and that's very common. But as soon as you make them tokenized and you make it so you can't jump over them or go through them, then all these sort of expectations fall down and people stop having a terrible experience. So we wanted to fix that as well. We wanted to fix a category of accessibility issues, performance issues. So there's so many things we wanted to do, but actually what that was an interesting outcome from that was we spent a lot of time just understanding how to like get sort of like the runtime characteristics right for very difficult problems. So now I come to Svelte, I'm like, oh, what are we doing here? And it's like, oh, event listeners and like typical UI things. It's such a relief to not have to deal with like, IME on Firefox. So, yeah.
Well, I love that you put I am IE and Firefox in the same. I'd go ahead and stuff Safari
in there.
Safari Mobile in there typically is my arch nemesis when it comes to text editing.
But I love your background because, you came from the smallest, I feel like, and then, just like optimizing, because I think through like 2017 through 2020, I feel like, and probably even now, right? But, we would do state of JavaScript and everybody's just talking about making things smaller all the time, right? Like the updates are, well, we made it smaller. Well, it's smaller now. We rewrote it to make it smaller. So I think that's really great. And you bring up such good points about, other countries, I would say, or, people with slower phones, let's say, right? And having issues. I was so surprised when I went to India and everybody's like, oh yeah, we can't use routers because that's just not a thing here. It just doesn't work in our country. And I was like, oh, wow, I didn't even realize. So, but yeah, so how do we find you? Like, where can we find out more information? Where are you hanging out these days?
For me, you can follow me on Twitter, see what I've got going on there. Ping me if you have any ideas. I'm also on Discord as well on the Svelte channel there, so you can find me on that server and ask away. Otherwise, in terms of like what's happening with Svelte and like hopefully we'll have some details to like share with people in the coming month, I hope. That might be very brief or overview-ish details rather than very precise details, but we hope to have something.
I mean, that's really exciting because I was like, I was poking around and asking when, Svelte 5 was going to be released, and somebody said, maybe December, but I'm like, what do you think?
I love that Svelte 4 just came out, and the first thing Tracy asked, the first thing out of her mouth is, that's great. When's Svelte 5 coming out?
But that's what everyone's asking,
Classic
right?
user.
Everyone's like, yeah, this is just a primer to Svelte 5 where
3 years we built
stuff will
Svelte 4, and you're like, that's nice. Push that aside. When's the next one coming? It's just like, come on, users. Like, come on.
What I can say is we've been exploring things around. Just before I joined Vercel, actually, I was working on a project called Octane, which was kind of my own revisited what I'd like React to be. So it was compiler driven, it used signals, whatever you wrote in, the components never re-rendered, even though you'd had hooks and everything else. It's kind of very state of the art. But a lot of the work that went into that project, I've kind of seen how we can take that and bring it to Svelte. So like the good ideas we bring along, the bad ideas we leave behind.
That's awesome.
So that's kind of where we've kind of started. And so I've been working on a sort of prototype to see what is possible.
Yeah.
And what works and what doesn't work.
And that really is the best. That's what I love about innovation, right? It's like you can take everything and kind of start from a blank slate almost. I feel like that's what Vue did when kind of Vue started rising to fame, leaving all the bad bits and taking all the good bits. But no, it's really cool. So we can't wait to see what happens. And we'll stalk your Twitter and your GitHub and figure out which commits you've been making so that we can like pinpoint what's next for Svelte. But yeah, thank you so much for joining us. And thanks, and we'll see you soon.